Right, so in the previous segment we discussed something called the kernel mode. So that is, so now that we know, we've spoken of this word called kernel, I think this is a good time to look at what the kernel is. So the kernel is a part of the operating system which contains the most important functions. So let me remind you again that the OS is a program, it's a software, it's a bunch of lines of code, and as with any code you and I write, there are some lines, some functions, some blocks which are most important. They contain the core essence or the logic. So that is what is contained in a kernel. So for example, if you take a C program, let's say you have a menu driven program with 4 options, some add, subtract, reset, exit, whatever. So you have the main program where you write the menu driven logic, and then you have separately defined functions for each of those 4 options. So the main program, int main part, is more like a user interface, in the sense that this is the part that is going to interact with the user, get their input, preference, and do whatever they ask you to do. The functions you have written separately, the user defined functions, are the essence, the logic, or the heart of your function or application, so to speak. Similarly, in an OS, there are a bunch of functions, a bunch of instructions to perform a bunch of tasks. Some of them, the core, the most important of them, are called the kernel. So the other parts of the OS may vary depending on architecture and modularity, but the core remains largely intact. What do I mean by this line? So if you look at the types of OS, there are different architectures. Like there is something called monolithic, something called layered, something called modular, etc. So these deal with how your OS code is written. So if you take, going back to our C program example, there are different ways of writing the same end program, right? So the end result or what it's performing will be the same, but the way you write it can be different. So in the menu driven program, you can write the functions within the main itself. So int main, if choice equals 1, do this, else if choice equals 2, do this, else do this. That is one way of writing. Or else you define the 4 functions separately, and then in the main program, if choice equals 1, call this function, else if choice equals 2, call this function. That is one way of writing. Ultimately they do the same task, but the modularity or how you break it down into modules, into components, is different. Same thing with the OS. There is something called a monolithic architecture, something called a layered architecture, something called a modular architecture, and so on. So in different architectures, the code is broken down into components in different fashions. So in monolithic, everything is put together as one big program. Like you're writing your subfunctions inside the int main part itself. In layered, the different functions are separated on the basis of their uses. Like all the hardware related functions go in one bunch, all the input output related functions go in one bunch, and so on and so forth. In modular, again, they are separated based on the tasks they do, scheduling related, memory related, file management related, and so on. So what this third point on the slide says is, whatever is in the kernel remains largely the same across architectures, because those are the core, the essence, the soul of your operating system. They remain mostly the same. The remaining part is what you can segregate into different modules or layers or whatever. So the kernel is the core, the most important functions of an OS, without which it cannot work at all, go into the kernel. So it contains instructions related to process scheduling, memory management. The most important functions basically lie in the kernel.